Hello and welcome to BlastOne. This afternoon we're talking about compressors. Compressors come in many forms, shapes and sizes. It's important to recognise what your requirement is in relation to the amount of air that you're going to compress to do the job adequately. This afternoon we're going to be talking about a 400 CFM compressor, and we're just going to run through the general maintenance requirements in relation to a compressor on site. So the first thing we're going to do is look at the environment. What effects are this compressor going to have on the environment? Is it going to produce too much exhaust in relation to where I'm working? Is the environment level? So the most important aspect of these particular units is they must be set on level ground. So with this particular jockey wheel, I'll ensure that the compressor is brought to a level status. Also too, it's important to install the park brake. Compressors also come with wedges. Wedges are sat behind or in front of the wheel, so fore and aft of the wheel, to ensure that the unit cannot roll or move whilst raising or lowering the jockey wheel, to ensure that the unit is level. So as far as the housing of the compressor is concerned, I'd make sure that the compressor is not set on the downside of the wind for spray painting, primarily because the overspray will end up all over the unit and you'll either have to clean it or the person that you've hired the machine off will be very unhappy with you. So ensure that the environment that you've installed the compressor in is appropriate in relation to your requirements. So with any compressor we have several outlets. You'll see that these are inch mince-up couplings and a 2-inch mince-up coupling. All of them have valve handles on them. So before starting the machine, make sure they're all off. Primarily because the operation of the machine is driven from here, so you'll be standing there. So ultimately you won't start the machine with these valves open. The other aspect of it too is that those valves need to be closed because the compressor needs the capacity to read the pressure feedback to start and appropriate the air in conjunction with its normal operation procedure. Most compressors nowadays have a computerised system in there. It makes it easier for the operator. Also too, as far as that is concerned, the operational panel, there is always a start and stop procedure and a warning in relation to what can hurt you in regard to this particular machine. Well, it turns and burns, so there's all aspects of it that you have to be conscious of. One important requirement with these units is they all have opening doors, lift up doors, to give you access to either side of the compressor, battery, fuel and so forth. It's important to ensure that during operation all these doors are closed because the compressor draws the air in the appropriate ducting rather than just open air, so it needs the fan to have the external air or an environment drawn through the machine to cool it in an appropriate manner. So it's designed as such, not to have the doors open. Also too, if you leave the doors open, you leave it exposed to the elements, and if you're grit blasting, the grit and dust will end up inside the machine, which is detrimental to its long-term operational qualities. So as far as operating the machine is concerned, yes, there is the fundamental requirements to start, check engine oil, coolant, fuel, compressor oil, all of those items. So just to quickly run through them for you, before I start anything, I ensure that the machine is level, the handbrake is engaged, chains and so forth are up out of the way so no one can trip on them. The machine does have a fire extinguisher, which is powder, which is indicative to the type of fire that this machine could have. So if you do all the appropriate checks, you eliminate such possibilities of fires, damage, danger and so forth. So to check the oil on the machine and to check the battery and functionality, you'll need to open the appropriate doors to give you access to those particular items. With a diesel engine, which most of these are, you'll very rarely find a petrol driven one. Because they're diesel, there's only two things that will stop a diesel engine, which is fuel and air. So if it doesn't have fuel, it won't go. If it doesn't have air, it won't go. So where does the air come from? It's filtered through and sent into the naturally aspirated, or in some instances they have a blower on them, so it needs a lot of air to actually keep the engine running to its optimum and to reach the revs required to maintain functionality of the compressor, which is the part that you're concerned with. So the first thing I do, if the compressor's been sitting around for some time, is I'll access this particular door here, which will give me access to the battery. So the battery normally has an isolation switch with it. So what an isolator does, it interrupts a current. So with any electrical system, it has a flow through or a current system that has to be followed. So where it goes in, it must return. So to interrupt that return of electrical current, they'll put an isolation switch in there. So the isolation switch is designed to make this control panel inoperable when that's been initiated. So the first thing we'll do is we'll check to make sure that we have the isolation switch engaged to give us current. And if the compressor's been sitting for some time, it's probably a good idea to check that the battery has enough charge to start the machine. For that requirement, we have a circuit tester or an amp gauge to see if we do have adequate amperage and voltage to start this particular machine. So with that in mind, what we'll do is we'll put a probe on the positive side and the negative side of the battery, and we'll check to ensure that we have adequate current to do the job. So in this case, what we're looking for is 12 volts. So what I need to check here is for fuel. Because it's a translucent tank, I can see how much fuel's in there without even taking the cap off, because I get some indication just by looking at the wall of the tank itself to see how much fuel there is in there. As I said, this particular machine will tell you how much fuel's in it anyway. It also has a low fuel cutout, so if it runs too low on fuel and you haven't checked it for the day, it'll cut out before it actually runs out of fuel, so you're not starving the pump and the injectors of fuel, which would cause you another problem. So what it does expose with this particular door open is the ability to be able to check the oil in the unit as to how much oil it does have in the crank, or in the sump I should say, and to ensure that there is adequate oil in there in accordance with the manufacturer's recommendations. So basically what you're looking for is that oil stick to show you that it's full. Also too, on this side, if you do require oil, wipe any dust and excessive dirt away from the filler, and that way you'll undo the filler and replace the oil or replenish the oil sump capacity back up to full on the stick. Also too, you can see here that we have another filter, which is the fuel filter, and it says here drain water regularly. Well, basically this particular machine does it automatically. Most of them do now, the new ones. These filters are primarily changed in accordance with a maintenance regime. So X amount of hours means the filters are changed. That's fuel filters and oil filters. Also here it exposes for us with this door open how much water there is in the cooling system. So gone are the days when you had to look in the top of the radiator cap. You can check it here to see where your level is. Now on this particular one it says cold and hot. So obviously when it gets hot there's more fluid because it expands, so the level may rise, but here it gives you an indicative level as where it needs to be when it's cold. So if it's below that, of course, you'd top it up. Also underneath this hatch is the air cleaners. The air cleaners are required to filter the air that goes into your particular turbo and also into the naturally aspirated engine side of things. So to check the filters, to see how they are within the environment that you're expecting it to function, there's the 3 clips on these filter housings which ultimately expose the filter. Now just from a visual aspect, you can check the pleats in the filters to see if they are congested. And also too, it doesn't hurt to give this a wipe out with a piece of rag each time you take it off to ensure that when you reinstall it, there's no excessive dust in the base of it, and this is always pointing to the bottom. So again, by checking the filters, you ensure that this machine will work. Diesel engines, if this particular filter became blocked, it won't run at all. So it needs a lot of air to make sure that it will function in the appropriate manner. So ensure that when you put them back on, those clips, that they are in the appropriate places, and they do pull the cover back in nice and tight. If the cover's crooked and doesn't go back in place, you'll have excessive dust go in from one angle of this particular housing cover. And this particular one is the same. So the filters need to be checked periodically to ensure that they are clean and not congested or contaminated in any way, shape or form. So this particular machine is in quite good repair as far as maintenance is concerned. It's relatively clean, it's only minor dust inside the cover, and the pleats are quite clean and in good repair. So I mean, remember, when you put this, see here it says top, so just make sure that it's near the top or at the top, and reinstate the clips to pull the housing body cover back into place. So what else is there to check? Well, if the machine's been running, the last thing you'll do is put your hands on any of these items because they'll be hot. And of course they've installed guards into areas where there's items that are spinning, like the alternator here that sits up the top. So obviously there's a guard there for a reason. The reason is that you don't put your hands anywhere near those particular items. So with the machine stopped, you'll check fluids such as diesel, water, oil. So by checking those prior to starting is the best way. That way I'm not coming back in here when the machine's hot to look at these particular items and run the risk of being burnt from these exposed areas that will be hot. When you finish checking all of these particular items, it's important that you reinstate the hatch or the lid back into its appropriate position to ensure that the cooling aspect of the machine works appropriately in accordance to manufacturer's recommendations. So on this side of the unit with this hatch open, what it exposed for me is oil separator. So what I'm looking for here is to ensure the compressor has enough oil. This here holds the amount of oil that's required for the compressor. So normally what they'll have on these is a sight glass. So in this particular unit, the sight glass is down the bottom. It's a little bit awkward to see, but if I just bend down and look inside there, that shows me the sight glass will show high and low. In this particular case, it's showing high, full level, so good. While it's all cold and I haven't started the machine, I can check hoses and do a visual check of all these hoses to make sure that everything's tight, nothing's come loose, and to ensure that the safe operation of this particular machine is maintained. So if I see leaks around any of these items, so there's a filter here for this particular oil, I make sure that there's no leaks, nothing running off, all the wiring has not been rubbing up against the harnesses, against the frame itself. So if I do all those visual checks before starting, I ensure the safe operation of this machine is maintained. So to start the machine, I've done all these checks. So these checks are written up here for you as a ready reckoner to ensure that all of this is appropriate to start the machine. It'll also have a service date compliance, which is completed when they service the machine. So you need to check that periodically to make sure that you are in accordance with the due date or compliant with the requirement as far as maintenance is concerned. It's important you understand all of these fundamentals before you push this start button. Most of these machines now will have an emergency stop. So the emergency stop consists of the switch being depressed, which isolates everything on the machine. When I say everything, it's the electrical system, so you can't start anything. So make sure that that is clicked back out again, because it doesn't matter how much you press these items here to start the machine. If that is depressed, nothing will actuate. So with the emergency stop released, I can now start the machine. So is it level? Yes. Are the valves off? Yes. Is the park brake engaged? Yes. Have I checked all the fluids? Yes. Everything looks good to go. So now, in accordance with the start-stop procedure, I can go from stop to on, over to start with a warm-up control, and push the start button. The red light comes in, I've got 30 seconds to do that. The machine started immediately. So now it's in warm-up procedure. Leave it to 30 seconds to warm up. The computer's now telling me how many revs it's doing with the 1600, very good to start up with. So the valves still remain shut. I can't do anything until I've let it have its warm-up procedure, which is 30 seconds. So be patient and let the machine warm up. Premature pressure or pressure requirement on the machine is too much of a shock for the system. So just waiting that period of time, watching your air pressure coming up, watching compression temperature. Won't move for a while, of course, because we haven't been operating long enough. So now you notice I've got all the hatches shut. Everything's been engaged as far as the handbrake's concerned. The machine is level. Now I've waited the appropriate time, I can go across from start to run. Now what's happened now is it's come up to 120 psi. And now I've got volumetric air being created because the pump, the compressor itself, is pumping adequate air to facilitate what I draw off here now. So now I'm in this particular setting. I'm making air. Now I need high pressure air. So now you'll hear it chase it again, which brings it up to 140 psi. There you are. It's just chased itself. With these valves off, I can appropriate the hoses with large radiuses for the bull hose, with safety clips and whip checks. Any accessorising air I need, I can run these off these small A-type couplings with pins, with whip checks. So whip checks, pins for all of those particular items. So remember, this is a 400 CFM compressor. The fundamentals remain the same for a smaller compressor or a larger compressor. Check your fluids, check your oils, battery, so forth, and all of this appropriate safety equipment, even a fire extinguisher. If you have all of those fundamentals in place, you should have safe, happy operation. When I've completed what I need to do, finished for the day, what does it say here? It says start, run. I leave that alone, pressure high or low, it doesn't matter, because the machine is going to decompress or expel any air, excessive air that it's got. So when I've finished for the day, all I need to do is walk back to the machine, check everything's safe, shut down the machine. Now as I shut down the machine, you'll see that it's exhausting the air through the aftercooler anyway, and the machine is deemed safe. Any excessive air can be exhausted out through these taps, but it will, as you can see, it's losing air now, it's decompressing, so there's no need to worry about exhausting any air. Years ago we used to leave these valves open, whereas now times have changed, we leave them shut. The point is too, if there was any problems with this compressor, I would tag it out and initiate the isolator. I'd probably take a terminal off the battery, but also too, I'd tag it out so that the machine couldn't be operated. So there's no need to depress the emergency stop. It is primarily, as it described, for emergencies, and that's the only time you need to depress the stop. So when I'm finished for the day, what do? I make sure that all of these valves are off, the handbrake's engaged, and tomorrow morning I'll do the whole procedure again, check my fluids, check to make sure that the battery's okay, and as I say, this computer interface, mainframe interface, will tell me all of the stuff that I require to do to initiate an appropriate start and maintain good running operations for the machine itself. So as far as this chart is concerned, not only does it tell me what nozzle size uses what amount of pressure, but it also gives me an efficiency indication. So the indication on there is less than 100 psi, and I start diminishing in efficiency as far as my blast operation is concerned. So it's important to remember that when you get a compressor, make sure that it's adequate to fulfill the requirement of the blast pot, the air prep, your breathing air helmet, and the blast nozzle in which you select. So say for example, I got a compressor that was ended up on site that was too small. Basically all I need to do is come back in nozzle size. Yes, it affects my productivity. Yes, I don't do as much as I expect to do in a day. But more importantly, I still maintain a blast pressure of around 100 psi. If you're under 100 psi, you are wasting grit, you are wasting your time. So always keep that pressure up around the 100 psi. There's nothing wrong with going with the bigger nozzles after you go over number 7. There's absolutely nothing wrong with increasing the air pressure up to 110 to 115 psi. What that does, it increases your productivity and makes the cut a lot more appropriate. So this chart gives me an indication of what size nozzle I need, absolutely. But also too, it's important to remember that the compressor selection that you make has to be able to provide adequate air to facilitate the appropriate outcome of this particular nozzle. So on the side of the chart where it nominates efficiencies, you're looking for efficiency of 100%, of course you are. So consequently it'll go across for a number 7 and tell you that you'll need 312 CFM of air. So a 400 CFM compressor would adequately do a number 7 nozzle with the blast helmet, which will take about 30 CFM of air to run at optimum. So if you don't have the appropriate air to run that number 7 nozzle, you're wasting your time trying to blast with inadequate air. So what I suggest you do is come back in nozzle size, which reduces the CFM requirement for that particular nozzle to appropriate the appropriate outcome as far as blasting is concerned. Not enough air, wasting your time. Come back in nozzle size, reduce the orifice size of the nozzle, which holds up the air, which enables you to the appropriate velocity to achieve the class of blast that you're after. One thing I will make mention of is that now that I've finished with the compressor, I need to take the wedges from the rear wheels fore and aft. I also need to leave the handbrake engaged. I can now raise the drawbar with the jockey wheel. I can also make sure that the coupling is upright. This particular tag here is for reversing. So it's been reversed into position. So what I'll do now is lift this tag, and that'll allow the shaft to come back and operate these brakes here, which are hydraulic. And also too, by removing the retaining tag, when I go forward now, it'll only be dragged forward, so this becomes null and void for towing operation. Make sure that this coupling here is lubricated. Make sure that the dog, when you lift it up and down, needs periodic greasing. And also too, you can use the same linch pins you use in these particular couplings. You can also use them to hold that dog in place. So when this is coupled to a drawbar, which is 50 millimeters, this retainer here can be kept into place or position by this particular pin. So you see it can't come off the drawbar. Safety first. These particular chains here also maintain the harness of this particular unit to the vehicle. They always have They'll always have 2 chains, the heavier equipment, and they will also have the ability to be able to fasten these particular chains to the vehicle as well. The important thing to remember is there's nothing wrong with putting a bit of anti-seize on here. I wouldn't use oil because the oil or grease will make them sticky with dust, but a bit of anti-seize or even a bit of graphite dust is good on these to keep them in good repair. So the pins always go back in. Don't do them up with a shifter or a spanner because they can become quite difficult to undo. So remember that when you harness this to a vehicle, these are mandatory, they must go on. This tag here is only for reversing. Make sure that the unit does have adequate brake fluid, which it has, so that the functionality of the hydraulic brakes is operational, adequate fluid. And this particular one here is a secondary park brake, so to engage the secondary park brake, I push it forward until it becomes difficult to push any further or depress that piston and engage that dog clip or claw clip. So what happens is by engaging that, that's holding the hydraulic brakes on in conjunction with this particular one as well. So before I decide to move the vehicle or move this particular trailer away from its position, of course, what I'll do is I'll couple it to the tow vehicle, make sure I engage this pin and the dog comes in behind and pinches on the ball. These chains are attached appropriately to the tow vehicle. Only then will you disengage these particular brakes, this one and this one, and ensure that you release the torque off the stem on the jockey wheel, and then your quick release is pulled out and the jockey wheel is pulled up out of harm's way so that it doesn't get damaged or broken. So if you follow all those procedures, and of course this particular plug, which accommodates lights on the trailer, once you plug this in, it's a good idea to then go to the rear of the trailer, ensure that all brake lights, park lights, indicators are working. If they're not, check to see that the pin's clean and clear. Re-engage the pin to ensure that it is all the way home, and there's a keeper that comes in behind that to hold it in position. So lights must work, brakes must work, all the coupling units available to you must be engaged. As I say, only then we release the jockey wheel once the weight is taken off this particular trailer drawbar by lowering the jockey wheel and letting the weight come onto the tow vehicle. Then you can disengage your handbrakes, park brake, jockey wheel up out of the way. So hopefully that gives you a good functional run through of how to appropriate your compressor